One of the most impressive scientific discoveries of humanity is the discovery of molecular composition, built on centuries of curiosity, experimentation, and breakthroughs. It's a journey that starts with ancient philosophy and leads to modern-day technology, unraveling the mysteries of what everything around us is made of. It started in ancient Greece, where philosophers like Democritus suggested the existence of atoms, small, indivisible particles making up all matter. Although it was a very radical idea at that time, it had no evidence and was just philosophical for centuries. It's the 17th and 18th centuries, with scientists experimenting in gases and chemical reactions. In this era, Robert Boyle comes along, now known as the father of modern chemistry, arguing that substances are comprised of elements which cannot be divided further. Thus, his work was the ground for understanding what matter's all about. Antoine Lavoisier was able to revolutionize chemistry in the late 18th century, discovering the law of conservation of mass, thereby proving that in a chemical reaction, matter cannot be created or destroyed. His extremely careful experiments demonstrated that water, for instance, was not an element, but rather a compound of hydrogen and oxygen. This is a crucial step in understanding the composition of molecules. The 19th century was a major leap with John Dalton, who formalized atomic theory. He proposed that elements were made of identical atoms, and these atoms combined in fixed ratios to form compounds. Dalton's work explained why water always consisted of 2 hydrogen atoms and 1 oxygen atom, introducing the concept of molecular formulas. Around the same time, Avogadro's hypothesis helped clarify the relationship between atoms and molecules. Avogadro proposed that equal volumes of gases at the same temperature and pressure contain the same number of particles. This idea eventually led to the determination of molecular weights, bridging the gap between atomic theory and measurable properties. The discovery of spectroscopy in the mid-19th century transformed our ability to identify molecular composition. Scientists such as Gustav Kirchhoff and Robert Bunsen used light to analyze the unique spectral fingerprints of elements. This technique revealed the composition of substances, from Earth's minerals to distant stars, and became a cornerstone of molecular chemistry. The 20th century saw even further progress. X-ray crystallography helped us, thanks to William Henry Bragg and Willard Frank Libby, among other scientists, to directly visualize the atomic arrangement in molecules. Franklin's famous X-ray images of DNA revealed its double helix structure, revolutionizing biology and molecular science. Modern techniques, from mass spectrometry to nuclear magnetic resonance, NMR spectroscopy, take molecular analysis to awe-inspiring levels of resolution. They can identify molecular structures and even measure the exact masses of atoms within a molecule. Today, we can determine the composition of complex substances, from the proteins in our cells to the chemicals in distant planets' atmospheres. It is a testament to human ingenuity and curiosity, the journey of finding molecular composition. What started as a philosophical idea has evolved into a science of sophistication, unveiling the building blocks of the universe and empowering us to understand and shape the world around us. From ancient theories to modern discoveries, this journey reflects our relentless quest to uncover the secrets of matter itself.